Yeah, hi team, good morning. So today we can discuss about the physical backups. In the last session, we have seen about the logical backups where we have feasibility to take a single specific table, schema or database, or even we can take the entire cluster with the help of PG dump or utility. So we have seen different scenarios and today we can discuss about the physical backups. Okay, so in physical backups, we don't have feasibility to take a specific schema or a specific database or a specific table. As a part of your physical backups, we are taking the entire cluster files, okay? Because it's a block to block copy, we can say exact copy of your PG data directory. So that is our physical backups. So all the files resides in our PG data, right? So we have wall files, we have archilog files, we have data files, and all the system global files, everything, even the control file, everything resides under the PG data. So we have to consider PG data as a main uh, files or copy, exact copy to be taken as a part of our physical backup. Okay. So we'll discuss what are the different types of physical backups available and what is the inbuilt tools available in Postgres and what are the external tools we have to add some features. Okay, so we'll discuss about low-level API backups and PG-based backup and what is the PG backrest and ornament. Okay. So before we jump into physical backups, first we need to understand about the log management. Okay, so wall management. As we know, wall files is nothing but it's a redo files in our in Oracle, right? So basically, we have a folder called pg underscore wall in our pg data, which contains all our wall files. Okay, so each wall file size is 16 MB of size. Okay, and earlier this folder name pg underscore wall folder name, it is called as pg underscore xlog in older versions below version 10. Okay? So later they have renamed it from pg xlog to pg wall because few people like OS team, they are confused that they think this folder is like OS folder and by mistake they are removing the files in the pg underscore xlog, which is they are removing our wall files or red log files in this folder. Okay, so this if they delete this, then again it's a problem, right? So that's why they have renamed from pg xlog to pg underscore wall after version 10. Okay, so all our wall files will be stored in the pg underscore wall after version 10. Before the folder name is pg underscore xlog. Okay, and each wall files size is 16 MB of size, right? And it grows until 1 GB. So the maximum wall file size is 1 GB. So it will keep on growing. It will keep on generating the wall files of 16 MB until 1 GB. Once the 1 GB is full, then again it starts from 1. It will keep on override, right? And so basically we need to understand what is the wall file and how the wall file will be represented. Okay, so for example, if you see the wall file looks like this. So this is our wall file. Okay, F0, F1, and so on. So this is basically a 24 hexadecimal character, and among this, the first 8 characters represent the timeline. Okay, so it starts from 1, and whenever you do any recoveries or whenever you do any restorations, again the value will be changed to 2. This we can consider in Oracle like open reset logs, right? Whenever you do open reset logs, um, so again it starts from 0. So we can compare like open reset logs, but not the complete open reset. Here the timelines will keep on changing. Whenever you do a restore, recover, again the timeline will change to 2. Again, when you do restore recover, again it will change to 3 and so on. So the timeline value is very important. It's keep on changing whenever you do a restore or recover operations. Okay, it starts from 1, and when you start doing restore and recover, it will change, it keep on changing. So this represent the first 8 characters represent the timeline in the wall file, and the next 8 characters represents its logical representation. Okay, and the next 8 characters represent the physical representation. So finally, we call it as a wall file. So vol file is divided into 24 hexadecimal characters, and the first 8 characters we consider as a timeline, and the second 8 characters is a logical file, and the third 8 characters as a physical file. So total we call it as vol file. So this vol file resides under PG vol, under PG data location, right? So each size is 16 MB of size. Okay. Now, in order to actually similar like Oracle SCN number, okay, in Postgres, it represents into two formats. One format is log sequence number, and other format is transaction IDs. So whatever the transactions is happening, okay, it generates automatically a log sequence number. So we can able to see the current log sequence number. What is the current log sequence number in Postgres cluster? And we can also represent, and we can also see how, what is the physical representation and what is the logical representation of the vol files. So with the help of these functions, okay, this function will give pg underscore current underscore vol underscore lsn. This will give the current current lsn number. Okay, what is the current lsn number? And this will give the physical. So basically, this will give the logical representation, and this will give the physical representation of your vol file. So it will give the full name of your vol file, which we called as a physical. And we have offset. So offset is the currently where the line pointer is pointing to the vol files. Okay, even we can able to find out the offset of our LSN. Okay, so these LSNs will be automatically allocated by Postgres cluster based on your transactions. Okay, we need to keep track of our LSN currently where on which LSN we have current transactions is going on. Okay. Any questions so far?
Yeah, we are good.
Okay, thanks. So now we can go into the physical backups. Okay, so physical backups, we have two types of backups. One is offline backup and online backup. So offline backup nowadays, like no one is taking, right? So we can take in online. So basically offline backup means we need to shut down our entire Postgres cluster, and we can take the OS utility copy command, and we can take the backup with copy command or tar command. Okay, and then we can use that as a consistent copy, and we can use that as a restoring purpose. Okay, so basically to take the entire cluster physical backup in offline mode, we have to shut down the cluster, and after shutdowning the cluster, we cannot take a single table or a single database, right? So it's not possible. We have to take the entire cluster as a backup. So the entire cluster we can take as a consistent copy after shutting down the cluster with the help of tar command or copy command. So we have to take the entire data directory. So this is my data directory. I'm going to zip the entire data directory into backup.tar. So for this, we don't need any tools or utility to be taken, right? So we are just taking the advantage of OS command like copy or tar command, and we are just zipping everything in the backup.tar, all the data directory. Okay. And if you have any customized tables in place, we also need to take that particular OID zip file. Okay. So even that we need to take it. Okay. Because your so your table space, your customized table space folder is outside of your base directory, right? Or data directory. So even you have to consider those files to be taken as a part of your backup. Okay. So this is offline mode, and this is not preferable, and we are not using in real time. Okay, but this option is available whenever you want to test in any test environments to take this backup, and we can just copy this. We can just unzip this entire backup folder, and we can just start the cluster. Okay, with a different port. If it is in the same server, you have to set the different port and you have to start the cluster. If it is a different server, you can just copy the entire data directory and you can just start the cluster directly. Okay. So here restoration is nothing but we are just, you know, So we don't have any separate utility for restore. Okay, so we are just directly starting the cluster because we already have a consistent copy and we can directly start the cluster. Now, before we jump into the online backups, first we also need to understand about the checksum. Okay, so basically this checksum is to detect any block corruptions. Okay, if you enable the checksum, so this checksum will be able to detect any block corruptions happen in your pages. Okay, so basically whenever you initialize the cluster, we have an option called -k to enable the checksum. If you not enable this checksum as a part of your cluster installation, even later point of time, we have a utility called pg checksum. Okay, with the help of this pg checksum, you can able to enable the checksum of your cluster. Okay, but it requires a downtime. So your cluster has to be cleanly shut down before you run this pg checksum utility. Okay, so this pg checksum you can able to enable, disable, and you can check any block corruptions with the help of these three utilities: pg checksum check, pg checksum enable, pg checksum disable. Okay, so when you enable this, um, it will able to detect the block corruptions, but it will not repair those blocks or pages. Okay, it is just to identify. As a DBA, we have to take care if you have any corrupted blocks with the help of backups. Okay, this PG checksum inbuilt doesn't repair anything. Like Oracle, we have automatic block corruption and detection, right? It will repair. But here we don't have that kind of functionality. It is only detecting the block corruptions. Okay, it will just scan all the pages, and if it checks if it has any corruptions happen, that's it. So one more thing is, even to verify, even to check your checksum, you need a downtime. Okay, so you have to shut down your cluster even to run the check as well. It is not an online process. Okay, so you have to check it. So usually people, how they will do, they will not do on the current live system this pg checksum. So they will copy the backups to their separate server and they will test there. Okay, is there any block corruptions? Because we required a downtime, right? Even to check the pg checksum check utility, so we required the entire cluster to be down, otherwise it will not allow. So it will do the entire, it will scan all the pages and it will do the checksum if any corruptions happen. Okay, so whenever you enable this checksum, basically we have a value called checksum in the pg underscore control. So we have a control file in that we have a checksum. By default, it will be 0. Okay, 0 means it is disabled. 1 means it is enabled. Okay, so even we can check whether checksum is enabled or not in the control file with the help of pg control utility. We can just go and capture the checksum. If it is 0, means it is disabled. 1 means it is enabled. And we also have a few utilities or few parameters to check if your checksum is enabled or not. So this will show you how to enable the checksum. If you miss to enable the cluster installation, we can also check. We can also enable the checksum later point of time, but it requires the entire cluster to be down. Okay. So basically here we have to verify the entire cluster. Okay. Even we can verify a single file node, which means a single data file also we can verify if it has any block options. It's not only the entire cluster, we can also verify a single file node. Okay, with the help of this pg check utility. But only thing is it requires cluster to be down or even to check the pg checksum check command. Okay. So now we can go into the online backups. Okay. So in Postgres inbuilt, we can take physical online backups in two ways. One is using low-level API backup. The other method is using PG-based backup. Okay, so first we'll discuss about the low-level API backup. Okay, so low-level API backup is one of the online backup. So we can take the entire cluster backup as a part of your physical backup, okay, with the help of low-level API backup. So to take this low-level API backup, the important thing is your cluster should be in RK log mode. So we should enable our cluster in orglog mode because it's very important. Without this, we cannot. Okay, so we should make sure that orglog should be enabled at the cluster level. And in order to take this backup, first we need to keep our cluster into the backup mode. It's similar like Oracle hot backup, right? So you will enable the database in the backup mode, and you are taking the backups, and again you are disabling the database in the backup mode again back. Similarly, similar concept. So first we need to enable the database in the backup mode. For this, we are just using this function select pg underscore backup underscore start, and we are providing some label, which means the backup name, and this is default values is false. Okay, this is if you use here true, your checksum will happen very fast. So whenever you take any physical backups, forcefully Postgres cluster will do a checkpoint. Okay, but you have to use that option to do a force checkpoint. If you're not enable the force checkpoint, it has to wait until the checkpoint to be occurred, because by default checkpoint will occur every 5 minutes. Your backup will wait for 5 minutes and then only it will start your backup. Okay, if you want to issue your checkpoint forcefully, then you have to mention in the label, in the pg backup start function as a true. Okay, it will forcefully do a checkpoint. So basically, using low level API backup, you can take a physical backup of entire cluster. To do that, first we need to start the database cluster into backup mode by using select pg underscore backup underscore start function. And by default, the value will be false. Label means you can give any name, but this value is by default false. If you enable by default false, it has to wait your checkpoint to be occurred. We can say 5 minutes. Okay, and then you can take your backups. Okay, so once you enable your database cluster in the backup mode, you can use OS utility like copy or tar command, again whatever you want. And then once your backup is done, you can stop your database cluster in the backup mode by using select pg backup stop. Okay, so this is like hot backup in Oracle. We are keeping the entire cluster in the backup mode. We are copying all the PG data directory into the backup.tar file with the help of copy command or tar command, whatever you like. And you can, once your copy is done, you have to stop your cluster in the backup mode. Okay, this is the function we have to use to stop the cluster in the backup mode. Okay, so while you enable in the backup mode, you can just mention true. If you mention true, it will forcefully do a checkpoint and it will take the backup, because checkpoint is important, right? So whatever the data which has in the memory, okay, in the shared memory, it will flush to the disk, so that all the data, whatever recent transactions, will also come into your data files. So it's good to have a checkpoint. So that's why your inbuilt, it will do a checkpoint whenever we start any backup. It may be low level API backup or it may be PG based backup. Okay, so this is one kind of backup, low level API backup, and even this method is old, and like in older version they used to do, but in newer version, most of the people, not most of the people, almost all the people will use PG based backup. Okay. So any questions here about the low level API backup? We will see practically, okay, about these backups.
Yeah, one question. So, when do you do that? Like, when do we know that we need to the file system utility? What kind of utility is that? It is not a tar command or anything like that, right? It says backup the data directory, because these commands are pSQL commands.
No. From the pSQL, we have to keep this command. Okay, so from pSQL prompt, you have to run PG based backup start, and you can come out from the pSQL Okay, not in the same session. You can just open the other session. You can just take copy command or tar command. Okay, once done, you can just do pg backup stop. That's it. So
okay.
yeah, this is
just adding to like Suresh Malati. So here just start and stop is nothing but start is meant in Oracle we are going to keep database in backup mode, right? Okay, this is almost similar to that utility we can say.
Okay. That's okay. Go ahead. I will listen in the other one and then understand.
Yeah, probably when we discuss practical part, you will understand clearly. So first we need to keep first we need to keep our cluster in the backup mode by using this function. This utility is from the pSQL prompt, and it requires whatever the user which we connected to the cluster, it requires replication privilege or execute privilege. Okay, by default we use Postgres, right? It has a super user, so we don't need to worry about it. If you want to use any other user, we have this permission. Otherwise, we cannot run this function, because on this function it requires execute privilege. So that's why if you're trying to run this function with any other user, it requires this execute permission on this function. Otherwise, a super user doesn't require anything because it has all permissions. So we connect with the super user and just run this function. Once you run this function, internally what it happens, it will do a force checkpoint, and it will capture what is the current LSN and what is the current time and what is the current wall file. It will capture all those details, and you can just start copying all your files with the copy command or tar command at the OS level, your data directory. So once your copy done, you can just stop this function. You can run this utility to stop the backup mode. That's it. So it is just like same like Oracle hot backup. Okay. So we can take that backup pieces. We can take that backup pieces and we can start. Okay, the entire cluster. Okay, so it may be in the same server or in a different server. We can just copy and we can just start the backup. So the advantage in Postgres is it uses almost all the OS commands. Okay, it will take advantage of all OS commands, and not only for taking the backup copy and tar, but also even for setting the archlog mode. Okay, so we need to concentrate on two utilities or two parameters for enabling the database cluster in archlog mode. One is archive mode and archive command. So those are the two parameters which we need to enable to convert your cluster as a archlog mode. So even there, so it will use So there it will use the command copy to copy all your WAL files to archlog files. So we'll see practically how we can enable the database cluster in archlog mode. So most of the time, okay, even for backups or any other things, so your Postgres cluster will take advantage of OS utilities, and we can do that.
So when we enable this backup mode, so basically in background, so what will happen? So
in background, first it will do a checkpoint. Okay, all the transactions, whatever present in the memory, it will flush to the disk, which means it has all the data we'll have in the data files, and we are copying the entire cluster files, right? So at that moment, if any transactions happens, okay, it will be just freeze and it will not apply immediately, which means your transactions will not freeze. It will happen in the background, but all the LSN information and everything, whenever it has to update to the control file, right? So once your backup done, it will update all those details, whatever the current transactions, what it's happened. But once you enable the database cluster in the begin backup mode, for up to that particular point of time, okay, you will be taking the backup in the background. Whatever the transactions happen, it will be like it will update later point of time in like in the page header, and all those information will update later point of time, like similar like Oracle, same thing, it will happen.
Okay, so is it for entire cluster level, right?
Yes, it's entire cluster level. We cannot we don't have any feasibility to take a specific database or anything. So it is like enter PG data. So PG data is shared for all databases. It's like cluster level. Even whatever the archives which it's generating is at the cluster level, which means it is shared for all the databases, the archive logs. So we don't have feasibility to take a specific data file or specific database or specific table space. So we don't have that flexibility. We have to take the entire cluster. Okay.
Yeah, got it. So, yeah. So anyway, we can do this kind of activity if in case required, and we can do it in a minimal, application usage. But still, is there any recommendation from your side, like increasing this wall buffer sizes to more than 1 GB or something else to overcome any kind of issues?
Yeah, basically we will more concentrate on wall files whenever you have replication, right? So in replication, the case is different. So basically, otherwise 1 GB of your wall size is more than enough, because whenever each wall file is 16 MB, right? So whenever 16 MB is full, then automatically it will flush into archives. Okay, it will not wait until 1 GB your wall file should be full, right? Each wall file is 16 MB. So once your 16 MB is full, it will generate an archive. Okay, and until 1 GB it grows, your archives will keep on growing, right? So in that case, we don't need the default size, the 1 GB is more than enough, until unless you have a specific requirement, like you have any replication setup, or if you want to hold some wall files and archlogs due to some reasons. Okay, in that case, you can even we have you as a part of replication. Okay, even if your archive is not applied in the standby, so in that case, we have a parameter which will hold the archives even though after it reach 1 GB, it will not overwrite. It's keep on generating 16 MB file, and it's keep on growing. Okay, so when replication, the scenario is different, but otherwise for standalone, that 1 GB is more than enough, because anyhow we are it is generating archives after every 16 MB. Even though if you increase 2 GB, it's same, right? So we don't need to worry about it.
Okay, thank you.
Yeah. So that all cases, anyhow, we'll discuss even in the replication how we can manage everything. Okay. So, but again, if based on the workloads, okay, we have to increase the size, but for the normal workloads, that default size is more than enough. Yeah. So now we discuss about the PG based backup. Okay. So this is the most popular backup tool which they use in real time for most of the production systems. Okay. So before we discuss about this, let's discuss. Okay, let me share the screen again. So this is my PG cluster, and we have PG data, right? And we also have inside PG data, we also have PG wall. There is a folder called PG wall, right? And whenever we enable this cluster in RKLog mode, so to enable the cluster into RKLog mode, we need to enable two parameters. One parameter is archive mode. We need to mention on, and we have archive command. Okay, so these are the main parameters that we need to consider to enable your cluster to RKLog mode. So in archive command, we have to mention where we have to copy the archives. Okay, so basically archive log mode, whenever you enable, what happens, we have a background process called arc, which will write all your data from wall files to archlog files. Whenever your wall file is full, 16 MB is full, okay, it will write to the archives, right? So we have to specify where we have to copy. For example, we have to copy from wall files %p to, for example, I have to copy my archlogs in /home/postgres/org. Okay, in this folder I have to copy. So this is how you can enable this command, archive command. So you are taking the advantage of OS command, copy, and you are telling %p means copy from all files, where you have to copy to your archlog files. So %p and %f is the same. This is the default format, and it is the exact copy of your wall files. So your archlog is nothing but your exact copy of your wall files here. Okay. So these two parameters you have to enable in order to make your cluster in archlog mode. So now in the pg/pg_wall, we have wall files. It is 24 hexadecimal, right? So it represents something like this. Okay, this is the timeline, and it has the logical representation, something like this. Okay, and it also has the physical representation, something like this. Maybe A1. Okay, this is our wall file. Each wall file size is 16 MB. So under the PG data, we have PG wall where our wall files will be stored. This is nothing but our Redolog files in Oracle. Okay. So each file is 16 MB. And once the 16 MB is full, what happens? Oracle logs will be generated. So once the 16 MB is full, then it will copy the exact copy of your wall file to Oracle log location. Okay. And the next, it will write into the next file. Okay. And so on. So it will generate the next wall 2, wall 3, and so on, wall n. So here, what is wall n? Whenever 1 GB is full, okay, so whenever 1 GB is full, so 1 GB of 16 MB means how many wall files it will generate? We can say almost, yeah, so until 1 GB is full, okay, it's keep on generating wall files. So once 1 GB is full, again, it will overwrite from starting from 1. Okay, so once 1 GB of your PG wall file is full, again the data will write from here starting, and it will overwrite. It will write in the sequential format, same. Okay, this is how it works. Okay, this is once your 16 MB is full, anyhow it is copying to your wall file, your archlogs, even though it will overwrite after 1 GB, we don't have any problem, right? Anyhow, we have our archlogs in place. It will copy exact wall files to your archlog location, what you specify in the archive command. So any questions here?
Is there a way we can limit this? Like in Oracle, you specify how many Redolog files, right? Like 5 or 8 or something like
Yeah,
that.
we can only restrict with the size. Okay, we cannot restrict with how many wall files we need. So we can only restrict the size. The default size is 1 GB. Until 1 GB, it's keep on generating the wall files. Okay. So once 1 GB is full, then it will override. So if we want to less wall files to be generated, then we can reduce the size, maybe 500 MB. Until 500 MB reaches, it's keep on generating the wall files. That many wall files we have, we can manage.
Okay.
Yeah.
So is it for entire cluster level that we are
Yes.
enabling this archlog mode?
Yes, entire cluster level. Okay, it's not specific to database. So if you enable the archives at we have to enable at the cluster level. If you enable at the cluster level, this data may have all database data, right? So if you have D1, D2, D3, and so on, your D1 data may have here. Okay, and D2 data also may have here. D3 data also may have here. So your wall file is very important for all the database, right? It's the entire cluster level, not a specific database level. So until 1 GB is full, then it will keep on generating the wall files, and it will override once 1 GB of your PG wall become 1 GB, then it will keep on override. So this is how it works. Now, when coming to PG base backup, okay, so PG base backup. So basically, whenever you start this PG base backup is one of the inbuilt utility as a part of your binaries. You will get this PG base backup. So with the help of this PG base backup utility, we can take the entire cluster, okay, entire full database backup, okay, or entire full cluster backup, we can say. So we don't have any kind of incremental backup until version 16, okay. in version 17, they are going to release an incremental backup as part of your PG-based backup. So many people is going to outside tools like Barman and PG Backrest because of this drawback. There is no incremental backup. You have to go the full cluster backup as part of your PG-based backup until version 16. From version 17, they have introduced a new feature called incremental backup as part of your PG-based backup. Okay, for now, we don't have any incremental backup. If we want incremental backup, we have to go some third-party tools like Barman or PG Backrest. Okay, so now whenever you take the PG-based backup, what are the main files as a part of your backup? The main is PG data. Okay, so inside the PG data, we have all our data files, control files, wall files. Okay, everything we have under the PG data, right? And now, if you have any customized table spaces, for example, you have any customized table spaces outside of the PG data, even that customized table spaces also will be as a part of your backup. So now, whenever you are taking the PG based backup, we can take in different formats. We can take in the compression format or plain format. So when you take the PG based backup in the plain format, you have to use some options to take these customized table spaces. By default, it won't take the customized table spaces. Okay, in the PG based backup, we have an option called table space map. Okay, there you have to specify what is your backup location of your table space and what is the main table space location. You have to specify. But when you take with the TAR format, PG based backup will take care of your all customized table space as well. Okay, even these customized table spaces also, it will take as part of your backup. Okay, that anyhow we see practically also. Now, whenever you start the PG based backup, what happens internally? First, what it will do? It will do wall switch, and next what it will do a checkpoint. So if you want to do this checkpoint forcefully, okay, you have to specify here in the PG based backup, we have an option called -F for fast checkpoint. You can just mention that option. Otherwise, it will wait until the checkpoint to be occurred. Okay. So when you start this PG based backup, it will do these two tasks. And once these two tasks done, then what it will do? By default, it will enable your cluster into the backup mode. We don't need to run any function like start backup mode and so on. So by default, it will go to the backup mode and it will copy all your PG data, exact copy to your backup location. So whenever you are taking the backup, you will specify on which location I want to take the backup. Okay, there it will copy all your into backup folder. Okay, so this by taking this backup, we have different options. We will discuss more about it. Now, whenever you initialize the PG based backup, we have we have a utility called, or we have a parameter called max_wall_senders. So by default, this is a 10. So basically what happens whenever you start your PG based backup in older versions, it use a session. It will connect to the database as a session, right? As a session, and it will take the backup. Similarly, like Orman channels, right? Your Orman connection is also a database session, right? Similarly, your PG based backup also a session. So that session in older versions, they used max_connections, right? So we have max_connections. As a part of your max_connections, you have a connection established to the cluster, but they have separated for the backups for connections. That parameter is max wall senders. So whenever you initialize your backup with the help of PG based backup, it connects as a session with the max wall senders. Okay, so max wall senders is a separate channels or separate sessions for backup only, or for replication or for backup only. For those purposes, it will use this max wall senders. Okay, so max wall senders by default is 10, and when you use the parallel option, it will use these channels. Okay, these sessions we can say. So if you use parallel 4, it will use 4 max wall senders from here. Okay, they have separated from max connections to max wall senders, because if max wall connections is full, okay, your application will not connect, but your backup also will fail, right? So that is the reason they have separated your connections from max connections to max wall senders. So when you initialize the PG based backup, your max wall senders will be considered as a part of session. Okay, so by default it is 10, and based on your workloads you can increase this value. Other than the 10 is more than enough. Okay, for basic workloads. Any questions here?
Senders will likely keep processes to that will invoke or write.
Yes, we can say process, and it use that process as a session to take your backups.
Okay, we can increase it more than 10.
Yes, we can do that. Okay. So we can increase this more than 10 as well. Okay, so now, so basically we know that PG based backup is an online backup, and it copies the entire PG data as well as your customized table space. Okay, and this PG based backup you can take to a local any file system. For example, I want to take my backup into backup slash maybe this folder I have to take my backup. Okay, this may be a local machine, or you can also take this PG based backup to a remote server. Okay, so here you need to install PostgreSQL client. So when you install PostgreSQL client, you will get all binaries, right? So as a part of binaries, you have PG underscore based backup. You have a utility called PG underscore based backup as a part of your client. Now you can just take backup here with the help of PG based backup. You can connect -h, and this, for example, this host IP address is maybe 192.168.10.1. Okay, you have to just specify from remote machine what is your host name. But anyhow, you have to allow this client IP in the hpa.conf here. Okay, to make a established connection from remote machine to here, -h and 192.168.10.1. Okay, and you have to specify the backup directory with the help of -d. For example, I want to store my backup here. This backup directory is remote machine, okay, not local machine. So now what happens, you can take the backup here. What happens, it will connect to your remote machine, and it will fetch all your PG data and customized table space, and it will copy here. Okay, so your backup is here, your full backup. Now you can use this backup as your data directory, and you can start the cluster at any point of time. And even you can configure this archive command. Instead of copy, you can just use SCP, and on which remote machine you have to copy your archives. You have to specify this client IP address, okay, or this mission IP address here, so that your archives will directly copy to your remote server. Okay, for example, my archives is in /R. So all your production backups, all your production archives will be copied to the remote server. And if something happened to your cluster, you can directly start your cluster here. Just pgctl start, that's it. So you don't need any restore, you don't need any record. You already have all your backups in place. Okay, you already have all your archives in place. You can directly start your cluster here. Okay, so in real time, few people, what they will do, they will take a separate centralized backup mission, and from this mission they will connect to all your PG clusters, and they will take the backup into the remote server. Okay, and if something happened, they will directly start the cluster here. Not only the entire cluster, if some table is corrupted, if for example, they will start your cluster here, they will take the PG dump backup, and they can restore here. So this kind of options we have. So not only you can take the PG based backup into your local machine, you can also take your PG based backup in the remote machine as well. Okay, you have to point out your archives to the remote machine, and anyhow you are taking the backup from remote machine, your backup pieces will be available in the remote machine. So even this way you can do. Okay, so even in practically for lab, what we can do, we can take 2 servers. From this server, I will take the backup of remote server and I will configure my archives into the remote machine, and I can directly start my cluster. So your data directory may be in the same location, or it may be different location. I don't care. Okay. So we can directly start the cluster and you will have all the data up to date here. Okay. But you may have 16 MB of data gap, because once your 16 MB is full, okay, then only your archives will generate, right? So your archives will ship for every 16 MB. So in case of something happen, you may lose 16 MB of your data. So again, if you want to aggressive your checkpoint will occur every 5 minutes. If you want to do aggressive checkpoint, even you can reduce this 16 MB of your data loss as well. Okay. So this is how you can configure, whether you can configure your PG based backup in the local machine, and you can also configure in the remote machine. Okay. Now, we can not only take the PG based backup for the primary cluster, we can also take your database for the standby as well. So for example, you have a replication, you have primary and standby replication. Even you can take this PG based backup for your standby cluster as well. But for the standby, you have few limitations. Okay. So what are those? A few limitations means whenever you take a backup, it generates backup label file, and it also generates a history file. Okay. So this history file and backup label file is important because yeah. So what does this backup label file consist of? So all your backup, whatever the data files and whatever the files it has taken the backup, it has all those information in one file. So this PG based backup will automatically generate the backup label file. Okay. And this backup label file will have all your backup information, like what, so when the backup has been started and what files has took as a part of your backup. Okay, all data files and whatever files it has taken the backup, right? Those information it has here. And we have one more file called backup history file. So this history file consists of when the backup has been started, at what checkpoint the backup started, when the backup has been ended, those information will also have here. Only thing is this history file will not generate in the standby server. Okay. This is one limitation. And the other limitation is, so you cannot forcefully do a checkpoint as a part of your PG based backup in the standby. Okay. So when it is a primary, you have an option to forcefully do a checkpoint whenever you initialize the PG based backup. But for standby, you have to wait until the checkpoint to be occurred. Maybe 5 minutes you have to wait, and then only it will start the backup. So that limitation we have in the standby. Because since it's a standby, we cannot forcefully do a switch to a new wall file. Okay. So we cannot use hyphen. There is an option called -X to take the wall, to take the streaming. I mean, to take the current logs as well. Okay. So that option we don't have in the standby. Okay, that is one more. These limitations is for only standby. Okay. We don't have any limitations for the primary. For primary, you can take a backup as it is. Okay. It will forcefully do a checkpoint and it will take the parallelly PG data plus customized table space, and also it will take plus your RK logs or your wall files, we can say. So whatever the wall files which is generating, whenever you are taking the backup, it may generate like some 10 wall files. Even that wall files will also come as a part of your backup. Okay, it's like backup plus RK logs, we can say. Okay, so it will take your PG data plus wall files as well as a part of your PG based backup. For this, we have to specify one option, whether you need to take your RK logs backup or you only need PG data. Okay, there is an option called -X that we will show you. Okay, how we can take. So this is how you can configure your backups. And we have a view called PG stat_progress_base backup, where we can check the progress of your backup whenever you initialize the backup. So this is the view where you can check the progress of your backup, how much percentage it has completed currently, or how much data it has taken, how much MB of data it has taken, and currently what LSN the backup is going on. We can just check this progress by using this backup. Okay, so we will discuss when coming to slides. Do you have any questions here?
Yeah, here it seems to be we are taking the backup of only one cluster in the server, or how it will be, like, for example, I install 3 to 4 servers. I mean,
Yeah,
3 to 4 clusters.
Yeah. So if you install 3 to 4 clusters, so you have to take separate backup for that cluster. It is like cluster level. Okay. So one cluster you can take at a time using PG based backup. If you want to take the other cluster will be uniquely identified with the port number, right? You have to pass the port number here. So for example, I have this cluster 1 with the port 5432, and I have the other cluster in the same mission with port 5433, and I have other cluster with 5467, something like this. But you can just take you can just while you taking the PG based backup, you have to mention the port number so that it will take that corresponding cluster. Okay. But if you not mention any port, by default it will go and check for the 5432 and it will take that particular cluster backup.
Okay. So PG-based backup, does it require any recovery while restoring?
Yes, it requires recovery. That we'll discuss. What are the recovery options we have, and what types of point-in-time recoveries we have in Postgres. We have like multiple recovery options that we are going to discuss in the slides.
Okay. So is there any identification mark that because for entire cluster level there are so many databases, and for all the databases and archives will be stored in the same location, right?
Yes.
In replication part, how we can identify like this particular archive got missed from production for specific to this database?
No, we don't have such kind of things, but we have one utility called PG Wall. With the help of that wall file, you can just read this data, what data it has in the wall files, but you cannot identify this is from this database or something. So it has some kind of metadata entry. What exactly the wall file stores, it has the redo changes, right? So those redo changes we can able to read, but we cannot read that in the Oracle, but we can read that redo changes in the Postgres. You can only read what data it has, but you cannot identify because that table may have in a different database as well, right? So that kind of option we don't have. So we can just read this and we can understand that what is the start LSN and what kind of redo changes it has, like insert, delete statement, that kind of things we can read from this wall files. Okay.
And what is the complication of activity while I just want to move one database from one cluster to other cluster?
Okay. If you want to move only one database, you can go with PG dump and PG restore.
Okay.
But if you want to move the entire cluster, it's very easy. You can just take the backup directly to the remote server and you can start your cluster. That way will work. If you take the local, in your local, you have to copy the backup pieces to remote machine and you have to start recovery. So you have to copy all the archives. Okay, restoration is anyhow you have all the back PG data here. After the PG data, whatever archives you have to start in the recovery mode. Okay, that we will discuss how we can do the recovery of all, how to apply all the archives after the PG data. On the top of PG data, how to apply the archives. We can see that.
Okay. But initially, while you guys are configuring the clusters, so how you guys can identify which are all the critical databases? Okay, for these critical databases, for each second, this is the archive generation. So for that, I just want to set up specifically 10 databases into this cluster. So are you guys segregating initially while building any server or clusters?
Yeah, see, basically whenever you initialize the cluster, okay, so first we are taking the requirement from the application team, what type of data it is coming to the cluster, and how much sessions we can expect to connect to this particular cluster. And we have a utility called PG bench, okay, where we can do the benchmark test. For example, 100 sessions is connecting at a time and it is doing 1000 transactions. What is the transaction per second? What is the average rate it is getting? So we have a utility called PG bench as a part of your cluster. We have that utility. Okay. So with the help of that only, we can tune most of the parameters. So that all things we can discuss in tuning classes. Okay, don't worry. So based on that only, we have to decide the parameter values and all the necessary configuration changes. So based on the PG bench, most of the people will rely here. Okay.
Yeah, thank you.
Yeah, so that we discuss in the tuning class, how we can do the benchmark test for any new cluster. What are the main things which we need to configure as a part of the new cluster. Okay. So what we can do, we can discuss about the PG based backup tomorrow, because we have we just discussed in the paint the same things which we are going to discuss in the slides, and probably what are the main parameters and what is the recovery options we have, that we can discuss tomorrow, because because this will be fresh tomorrow again, when we start with the PG based backup. Again, in middle, we have to start tomorrow. So that is the reason we can start freshly about PG based backup theory plus practical part tomorrow. Okay. Yeah, any questions so far? So don't worry, still we have so many things to discuss in the PG based backup. This is just a basic things which we discuss. So we will also going to discuss what are the restore options and recovery options available, and what parameters we need to enable, and how we can do different types of point in time recoveries, what options we have. Those things we will discuss tomorrow. Okay. Okay.
One question.
Yeah.
You have mentioned like to take this online backup, it needs to be in archive mode, right?
Yes.
So if the cluster is not in archive mode, we set this parameter and then bounce the cluster like in Oracle?
Yes, it requires a bounce of your cluster to enable this archive command. At least you require a bounce back. So because this is a static parameter, you have to bounce the cluster for enabling your database in archive mode.
Okay.
Yeah. Any other questions? Yeah, so if no other questions, probably we can catch up tomorrow and we can discuss still more details about PG based backup and all the restore recovery options available, and how we can do the point in time recovery and how we can do the full recovery. Okay, so those all scenarios we discuss tomorrow. Okay. Yeah, so then thank you. We can catch up tomorrow for so the other so PG based backup topics. Okay, thank you.
Hey, one question. You were mentioning something about timing before I joined.
Timing? No, we have.
Is the timing going to be changed?
No, nothing. The same timings.
Okay, got it.
Yeah.
Thank you.
Okay, thank you. Bye.